All right, Unit 3 review. So starting with number 1, 3 to the 1/2 power. Anytime you have a fractional exponent, the denominator of that fraction becomes the root of the radical. So this is essentially the second square root of 3. So anytime you have 1/2, it's just going to be the square root of whatever that number is. You just don't have to write the 2. So if we came over here to 25 to the 7/2, it would be the square root of 25. But now we have the number 7. That has to go with the 25, and it can either go next to it underneath or on the outside. Either of these are going to be the same thing. Okay, when you have a negative one, so a negative exponent, you want to make that positive first by putting it over 1 or under 1. So the 13 to the 5/3. And then you would just rewrite that as a radical. So that would become 1 over the cube root of 13 to the 5th. So then down here for number 2, we just do the opposite. So we have a 3 as our root of the radical, so that's going to be a 3 in the bottom of the fraction. The other exponent's at the top, and then it's our base. Okay, so this one would be 13. 3 is the bottom, 5 is the top. This one is 7 is the base, 2 is the bottom, 3 is the top, and this one's going to be negative because we have a fraction. So it's the base here is 2, so it's actually 1 over 5 to the negative 1/2. And then you could just write it as 5 to the negative 1/2. Moving on to number 3. 3 and 4 are going to be similar in this way. So we have 8 to the 2/3. We'll start by rewriting this. So it's the cube root of 8 squared, or it can be rewritten as 3, the cube root of 8 squared. So that's going to be D and E, because those are the same thing. You'd end up getting the same answer. So then what we have to do is figure out what the cube root of 8 squared actually is. So we're going to go to math, go down to the cube root, type in 8, hit enter, and then square that. So 2 squared is 4. So 4 will be our other answer, and we also have A because 2 squared is 4. And that would be the same thing that you do for number 4. So for number 5, when we're solving for radicals, I'm going to do that on a separate sheet so that I can have a little bit more room. But the first thing that we're going to do is A. So let me write that down, 2x minus 3 plus 2 equals 5. And then I'll do B, which is 4x plus 1 plus 5 equals 2. Okay. All right, so this is A for number 5. You start by subtracting the 2 to the other side. So you have the square root of 2x minus 3 equals 3. And then to get rid of the square root, you raise both sides to whatever the number here is. So because it's the square root, we're going to square it to get rid of it. Then we're left with 2x minus 3 equals 9. And then it's just solving for x. Add the 3 over, so you have 2x equals 12. Divide both sides by 2, and your answer is going to be 6. For letter B, we'll start by subtracting the 5 to both sides. So you have the square root of 4x plus 1 equals negative 3. And a square root, 2 numbers that are the exact same, will never equal a negative, so this is going to be no solution. When you look at 6, though, these are all the cube roots. A cube root can be a negative, but a square root cannot. All right, for number 7, explain how we can tell from looking at the graph that there's 2 solutions. It crosses the x-axis twice. All right, 8 and 9 are going to be the same type of thing. So x is 3 minus 5i, y is negative 6 plus 2i. So then we're going to add them, subtract them, and multiply them. I'm going to focus on the multiplying because that's the toughest one. So you multiply them by boxing them. 3, negative 5i, and then negative 6 and 2i. Then you just fill in the box. And whenever you have I squared, that changes this number. So it's not negative 10I squared, it actually becomes a positive 10. All right, so 30i and 6i is 36i. Negative 18 and positive 10 is negative 8. And that's how you would multiply them. All right, for number 10a, for all these, actually, you want to get the parenthesis by itself. So actually, I'm going to do this one so you could see how it goes. So you want to subtract the 9 from both sides. So you're left with x minus 4 squared equals negative 9. And then this one, because this isn't the square root, it's a number squared, we're allowed to have a negative. All right, so then you would take the square root of both sides to get rid of it. And you're left with x minus 4 equals 3i. The square root of negative 9 is 3i. Add the 4 over, and your answer is 3i plus 4. And then the last one, 11, I'm going to do letter B. So x squared minus 9x plus 14 equals 0. A is going to be 1, B is going to be negative 9, and C is going to be 14. And it goes into this formula. Negative B plus or minus the square root of B squared minus 4AC all over 2A. So this is the quadratic formula that you have in your notes. This is the formula that we're going to use it for. And here's my A, my B, and my C. So I'm just going to plug these values in for this. Okay, so I have a negative 9, plus or minus the square root of negative 9 squared, minus 4 times 1 times 14, all over 2 times 1. So anything that was in parentheses was an A, a B, or a C, and I just plugged it in accordingly. Now we want to simplify. On the outside it's positive 9, on the bottom it's positive 2. That's plus or minus, and now inside the square root we have 81, and then negative 4 times 1 times 14 is negative 56. All right, so negative 9 squared was positive 81. This became negative 56, so we're going to subtract those two. 81 minus 56 becomes 25. So this is actually the square root of 25. We all know what the square root of 25 is, so it's 9 plus or minus 5 over 2, and this becomes two equations. 9 plus 5 over 2, and 9 minus 5 over 2. All right, so plus or minus becomes two separate equations. 9 plus 5, enter, divided by 2 is 7. So this one is going to be 7. And this one we have 9 minus 5 divided by 2. And that answer is 2. So these are your two solutions for that one.